Wind turbines have become an increasingly popular source of renewable energy. But like any large piece of machinery, they come with their own set of risks. Let's take a closer look at the top risks associated with wind turbines. Number one on the list is mechanical failure. Wind turbines have many moving parts that can break down or wear out, leading to costly repairs or equipment replacement. Common examples of mechanical failure include issues with the gearbox, bearings, yaw system, and brake system. Gearbox failure is one of the most costly and frequent mechanical failures, as it can lead to damage of other components and downtime for the future. Number two on the list is electrical failure. Common examples of electrical failure include issues with the generator, inverter, transformer, and electrical cables. These failures can cause power outages, equipment damage, and decreased energy production. Number three on the list is weather-related damage. High winds, lightning, and other severe weather can damage or destroy wind turbines. Number four on the list is fire. Fires in wind turbines can occur due to electrical problems or equipment failure. Number five on the list is blade failure. Blade failure can occur due to manufacturing defects, damage from high winds. Number six on the list is fatigue. Fatigue failure can occur due to the constant movement of the blades, leading to structural failure over time. Number seven on the list is ice throw. Ice throw can occur when ice builds up on the blades of a wind turbine, which can be thrown off at high speeds and cause damage to nearby people and property. While these risks are important to consider, it's important to remember that wind turbines are a proven and reliable source of clean energy. With proper maintenance and management, these risks can be minimized and the benefits of wind energy can be fully realized. Let's take a closer look at specific risks and insurance treatment for certain losses. Wind turbine blades are vulnerable to lightning strikes, which can cause significant damage and downtime for the turbine. To protect the blades from lightning strikes, wind turbine operators often implement lightning protection systems. These systems typically include a combination of air terminals, conductors, and grounding systems that help to dissipate the electrical charge from a lightning strike and redirect it into the ground. One common method of lightning protection for wind turbine blades is the use of blade strike protection, also called lightning diverters, which are devices attached to the blade tip. They work by creating a path for the lightning to follow, diverting it away from the turbine itself. This can reduce the risk of fire or damage to the turbine. Another method for protection is the use of early streamer emission, ESE air terminals. These devices emit a low-level electrical charge that helps to neutralize the charge in the surrounding atmosphere and reduce the likelihood of a lightning strike. It's also important to note that a comprehensive lightning protection system includes not only the protection of the blades, but also the nacelle, the tower, and the substation, and that these systems are regularly inspected and maintained to ensure that they are functioning properly. Overall, implementing a comprehensive lightning protection system can help minimize the risk of damage from lightning strikes and ensure the safe and efficient operation of wind turbines. One of the challenges of blade lightning protection systems is the protection of the embedded targets, which are metallic devices that are embedded in the blade to provide a path for the lightning to follow. These targets are vulnerable to corrosion, which can reduce their effectiveness over time. To protect the embedded targets from corrosion, paint or other coatings are often applied to them. The dilemma arises from the fact that the paint or coating applied to the embedded targets can reduce the conductivity of the metal, which can in turn reduce the effectiveness of the blade lightning protection system. This can lead to an increased risk of damage to the turbine from lightning strikes. To balance the protection of the embedded targets from corrosion versus the reduction in conduction caused by paint, engineers and experts in the field often recommend using specialized coatings, paints that are specifically designed for lightning protection systems. They also recommend regularly inspecting and maintaining the lightning protection to ensure that it is functioning properly and embedded targets are not corroded. It is also important to consider that the protection of the embedded targets is not the only factor to take into account in blade lightning protection systems. Other factors, such as the location and design of the air terminals, conductors, and grounding systems, can also play a significant role in the protection of wind turbine blades. Serial loss clauses are provisions in insurance policies that are designed to limit the insurer's financial exposure to a series of losses that occur as a result of a common cause, such as multiple gearbox failures in a wind farm. These clauses typically specify that the insurer will only cover a certain number of losses or a certain dollar amount of losses, beyond which the policyholder will be responsible for any additional losses. For example, a serial loss clause in a wind farm insurance policy may state that the insurer will cover up to 3 gearbox failures in a single year, but any additional gearbox failures that occur in that year will not be covered. Or a serial loss clause may state that the insurer will cover up to $5 million in losses due to gearbox failures, but any additional losses beyond that will not be covered. The purpose of the serial loss clause is to manage the risk of a catastrophic loss that could occur as a result of multiple gearbox failures. This allows the insurer to set a limit on their financial exposure and manage their risk while also providing coverage for a certain number of losses. It's important to note that serial loss clauses can vary depending on the policy and the insurer, and policyholders should review and understand the terms of their policy before purchasing it. Crane logistics for assessing a damaged nacelle on a 3 megawatt wind turbine can be a complex and costly process. It typically involves the use of a large crane, which is capable of lifting the heavy components of the turbine, such as the nacelle, blades, and hub. The crane must be able to reach the height of the turbine and have the necessary capacity to lift and maneuver the components. The cost of crane logistics can vary depending on the number of factors, including the size and complexity of the crane, the location of the crane, and the distance the crane must travel on to reach the ground. On average, the cost for a crane logistics for a 3 megawatt wind turbine can range from the tens of thousands to several $100,000. The wind turbine should be shut down during the operation, and wind speed and direction should be continuously monitored to ensure safe operation. It's also important to keep in mind that the crane logistics should be performed by a professional certified crane operator with the experience in wind turbine maintenance, as the operation requires a high level of skill and expertise. In summary, the crane logistics for assessing the damaged nacelle on a 3 megawatt turbine can be a complex and costly process. Whether blades must be replaced as a set versus repaired on an individual basis depends on several factors, including the extent of the damage, the age of the blades, and the cost of the replacement versus repair. If the blade is significantly damaged, such as being cracked or broken, it may need to be replaced. In such cases, it's often recommended to replace the entire set of blades to ensure that they are all the same age and condition. This helps to ensure that the turbine is operating at the optimal efficiency and to avoid any potential imbalance that could cause damage to the turbine in the future. If the blade is only slightly damaged, such as a minor nicks or scratches, it can usually be repaired. Repairing individual blades can be a cost-effective solution, as it allows for the continued use of the blades that are still in good condition. However, it's important to keep in mind that over time, blades will naturally degrade due to exposure to the elements, and the performance of the turbine will be affected. For this reason, it's recommended to replace the blades in sets when they reach the end of their expected lifespan, regardless of their current condition. It's also important to note that some wind turbine manufacturers require that blades be replaced as a set, and that any repairs or modifications made to blades must be done in accordance with manufacturer's specifications to maintain the warranty and ensure safe operation. So in summary, whether blades must be replaced as a set versus repaired on an individual basis depends on the extent of the damage. Wind turbine fires that are associated with obstructed air filters and unanticipated dust conditions pose a significant risk for energy operators. Air filters are an important component of wind turbines, as they help to keep the dust and other debris from entering the turbine's internal system and causing damage. However, if the air filters become obstructed due to an unexpected increase in dust conditions, it can lead to a number of problems. One of the main issues with obstructed air filters is that it can cause the turbine's cooling systems to become less effective, leading to overheating of the turbine's components. This can lead to a fire if the overheating is not detected and addressed in time. Additionally, to build up the dust and debris inside of the turbine can also create a potential ignition source for a fire. Another issue that can arise from obstructed air filters is that it can cause the turbine systems to work harder than they were designed to, which can lead to equipment failure and downtime. To prevent wind turbine fires associated with obstructed air filters, it's important to have regular inspections and maintenance of the air filters, especially in areas with high dust conditions. This can help ensure that the air filters are working correctly and any issues are caught and addressed before they can lead to a fire. It's also important to monitor the wind conditions and dust levels to make adjustments to the wind turbine's operations as needed to minimize the risk of obstructed air filters. In addition, having a good fire detection and suppression system in place and having regular training and drills for the personnel that can quickly respond in case of a fire. In summary, wind turbine fires associated with obstructed air filters due to unanticipated dust conditions can be a significant risk for wind energy operators. Regular inspections, maintenance, monitoring, and having fire detection and suppression systems in place can help to minimize this risk. There are several other causes of wind turbine fires beyond obstructed air filters due to unanticipated dust conditions. Some of the other common causes include electrical failures. Electrical failures such as short circuits in equipment, malfunctions can cause overheating and can lead to fire. Mechanical failures such as gearbox or bearing failures can also lead to overheating and lead to a fire. Lightning strikes. Wind turbines are tall structures that are often the highest point in a given area, making them vulnerable to lightning strikes. A direct lightning strike to a turbine can cause a fire. Human error. Human error such as improper maintenance or operation can also lead to a fire. For example, failure to properly lubricate equipment or failure to properly follow shutdown procedures can lead to a fire. Sabotage or vandalism. Wind turbines can also be set on fire by malicious actors, either by vandalism or sabotage. Weather-related incidents such as high winds, tornadoes, or thunderstorms can damage wind turbines and cause fires. Aging. As with mechanical equipment, wind turbines degrade over time, and the older a turbine, the more likely to have failure. It is important to note that wind turbine fires can be a significant risk for wind energy operators, and that it is important to have maintenance, inspection, fire detection, and suppression systems in place, and to have regular training and drills for the personnel that can quickly respond in case of a fire. There have been several developments in wind turbine fire protection in the recent years, aimed at reducing the risk of wind turbine fires and minimizing damage in the event of a fire. Some of these developments include advanced fire detection systems. Wind turbines are equipped with advanced fire detection systems that can detect a fire early and quickly alert the control room or the fire department. These systems use a combination of sensors such as thermal imaging cameras, smoke detectors, and flame detectors. Automatic fire suppression systems. Automatic fire suppression systems such as water mist systems and foam systems that can quickly extinguish a fire and minimize damage. These systems can be activated by the fire detection system or by manual activation. Improved materials and designs. Wind turbine manufacturers are developing new materials and designs that are more fire resistant and can withstand higher temperatures. These materials and designs can help to slow down the spread of fire and minimize damage. Remote monitoring and control. With the advances in technology, and wind turbines are now equipped with remote monitoring and control systems that allow operators to remotely monitor the turbine systems and to take actions if necessary. This can help minimize downtime and costs due to fire-related issues. Improved maintenance and inspection. Regular maintenance and inspection of wind turbines is crucial to minimize the risk of fire. Many companies are now using predictive maintenance techniques such as thermal imaging and vibration analysis to detect potential issues before they lead to a fire. Fireproofing of the nacelle. The nacelle is the most vulnerable part of the turbine. The industry is developing fireproofing methods for the nacelle, such as using fireproof insulation materials or applying fireproof coatings. These developments in the wind turbine fire protection are aimed at making wind energy operations safer and more reliable. It's important to note that these technologies are constantly evolving and improving, and that wind turbine operators should stay up to date with the latest developments to ensure that their wind turbines are protected against fire. The tower sections of a wind turbine are critical components that support the weight of the turbine and keep it upright. There are several risks associated with the tower sections, including corrosion. The tower sections are exposed to the elements, and over time they can become corroded, which can weaken the structural integrity of the tower and lead to failure. Fatigue. The tower sections are subject to constant stress from the wind and the weight of the turbine, which can lead to fatigue and eventual failure. The foundation of a wind turbine is a critical component that supports the weight of the turbine and keeps it upright. There are several risks associated with wind turbine foundations, including soil erosion. Wind turbine foundations are anchored in the soil, and over time, soil erosion can occur, which can weaken the foundation and lead to failure. Settling. The foundation may settle over time, which can lead to an uneven distribution of weight and put stress on the turbine. Flooding. Flooding can cause erosion and destabilize the foundation, which can lead to failure. Improper installation. If the foundation is not installed properly, it can lead to failure. For example, if the foundation is not deep enough or if the soil is not compacted correctly, it can lead to failure. Materials. Using the wrong materials for the foundation or using materials that are not designed to withstand the stresses of the environment can also lead to failure. Freeze-thaw cycles. If the foundation is not designed to handle the freeze-thaw cycles, it can lead to damage. In extreme cases, failure. To minimize the risk associated with wind turbine foundations, it's important to have a proper site assessment and soil testing before the foundation is designed or installed. Transportation logistics for moving wind turbine parts around the U.S. can be a complex and challenging process. The size and weight of the components, along with the need to transport them over long distances and through a variety of different terrains, can make both logistics a significant challenge. There are several key considerations when it comes to transportation logistics for wind turbine parts. Route planning. The route for transportation must be carefully planned to ensure that the components can be transported safely and efficiently. This includes considering factors such as road conditions, traffic, and weather. Permits and regulation. Special permits and regulations are often required for transporting oversized loads, and it's important to obtain these permits in advance and to be aware of any regulations that apply to the transportation of wind turbine parts. Equipment. Specialized equipment is often required for transportation, such as cranes, flatbed trucks, and specialized trailers. This equipment must be in good condition and properly maintained to ensure that it can handle safely the size and weight of the components. Timing. Wind turbine components are typically transported during the off-peak hours to avoid heavy traffic, and it's important to plan the transportation to avoid peak hours and peak seasons. Insurance. Ensuring the transportation is important, as the wind turbine parts are expensive and damage or loss during transportation can be costly. Coordination. The coordination between the transportation company and the wind turbine manufacturer, the installation company, and the wind farm developer is crucial.